A big thank you to all of you who like, comment, subscribe and share my videos, or through other means support this channel. You are what makes this channel grow and become a resource for other people to learn from. Enough about how awesome you are, back to the video. In this video we're going to be taking a very first glance at PCG, Procedural Content Generation, and see how we can start delving into it to see how we can make use of it for different things here. So here we have done a very simple example of how we can manipulate different information to create some placements of different trees and some plants, as well as these spheres here in the background, which are actually all individual actors that you could have blueprint logic inside of as well. So that's what we will be taking a look at in this video. Welcome back. So this is Unreal Engine version 5.2 preview 1, and we are going to be looking at procedural content generation as it is available currently. So starting off, I want to give a direction towards a YouTube page called, well, it's created by Adrien Lugon, which is a tools developer at Epic, where he will probably in the future keep releasing informational videos regarding how procedural content generation can be created or used in Unreal Engine 5. So that might be a good place to subscribe if you want to stay up to date with this kind of technology. But we're going to be looking at some of the basics that I have encountered so far while playing around with it. How this works is for procedural PCG is what its acronym is, and it stands for Procedural Content Generation. How this works is, first of all, we need to enable the plugin, and the plugin we can find in our plugins. And if you type in procedural, you can see here it's called Procedural Content Generation Framework. Select that one and click Restart Now to let the engine restart and update with the new plugin. Now that we have restarted, we can open up our content browser and we can create some assets related to PCG. If you right click, you'll see that you have a new category for PCG where you can create a PCG graph. So you have a few options here. You can either create it like this, and let's call it PCG test. And then you can drag and drop that into the world and you'll get, let's zoom in here. You can see that we have a volume created here. Another option for you to go about this is just going up here and placing an actor and then typing in PCG and then creating a PCG volume that way. With our volume created and our corresponding assets to it, we can see, let's actually do it full screen to begin with. We can see that we have this sort of blueprint-like interface that we are accustomed to. So in this scene, we have an input and we have an output, and we have a list of different nodes that we have available to us to the left, and we have some details here to the right. Everything is as is expected. The input here takes information from the volume that we have in the world. To show this off, what we can do is if we right click, we get access to all of these nodes that we have over here as well, but we're categorized here. We have samplers. Samplers are usually what you have as a sort of driving starting point to generate points. If we were to take point sampler here, for example, we can say that we want to generate points from something. So if we just take the input here and generate points, let's actually do this so we can actually see the world at the same time, something like that maybe. And let's do it like so. So now we should be generating points. We don't see any points to begin with because we don't have anything that we're doing with them. We can go into debugging mode. By right clicking, you can see that you have debug mode available at the key D as a hotkey. So we can just press D and you'll see that a bunch of things happen here. What is happening is the volume itself is generating a set of samples within the volume using this point sampler. And these points that are generated is what we get as a result from this. These points we can then make use of to do other things like spawning in items or things like that. For now, I'm just going to be explaining a few things here. Since this functionality is in experimental phase and it's easy to do something that is a little bit too taxing for a computer, be a bit careful, or at least a bit aware of that things that you do can potentially take a long time depending on the specs of your computer. If we were to do something like we wanted to generate a forest, this doesn't really do much for us. In that case, we wanted to have something that's on the ground, right? Like points generated on the ground somewhere. So point sampler in this case is not what we're wanting to have. If we right click and go to sampler, and then we can see that there's actually something called a surface sampler. This is something that makes more sense to us. We can disconnect this node either by holding over one of the inputs or outputs here, or just the line itself, holding down Alt and left clicking, and we will disconnect a line. Since we don't need to debug this, we can also remove the debugger for this one. If we drag into this surface sampler as our input and press D for debugging, you can see that we get some points, and they are flat. They are, however, on top of the volume. Not ideal for us in this situation. We can change what the input is supposed to be here. If we expand the input here, you can see that we have a bunch of different things. We have different pieces of information that are generated from within the volume. In this case, we could disconnect this surface and instead do landscape height, or just landscape if we wanted to. And you can see that we get these points now generated on our landscape floor. If we were to move this volume somewhere where the height difference is changing a little bit, like here, you can see that it generates points based on partly where the landscape is having its floor, but also where the volume actually encompasses the landscape. So if the volume is above the landscape, we won't get any points because we're not touching the landscape, and that's what we're using as our input over here. But as long as the volume is enveloping landscape, then these are points that will be generated for us as input over here. This volume we can of course change the dimensions of if we have the need for it. So we can see we have scale 25, 25, 10. If we change this one to be 25 as well, we can see that we have a much higher volume which we can encapsulate the landscape with easier. Okay, so now we have these points. What do these points actually do for us? We can, from this point on, make use of these points as sort of our positions where we want to spawn in trees, for example. So if we were to right click and we go to spawner, we can see that we have a bunch of different spawners that we can use for different kinds of things. One of these things is a static mesh spawner. The static mesh spawner takes an input of points, which is what we have generated here, so we can use that as the input. The static mesh spawner itself then needs to have some configuration done. In this case, we need to tell it what kind of mesh should we be spawning. So we'll be going to the marketplace to pick up some assets to make use of this. Now that we're on the marketplace, we have under the category of free, permanently free collection, we have a low poly style deluxe 2 tropical environment. So we'll add this to our project to make use of. When clicking add to project, we will be presented with all of our different projects, and your project will not likely turn up because this asset is made for 4.27 and we are using a project that is 5.2. So we'll just type in the name in this case and show all projects, and it'll say you can't use this because the versions are not matching. That isn't a big problem for us. We can just choose 4.27, add it to the project and continue from there. Alright, back in our project, we now have some assets to make use of. So if we open up our content browser, you can see that we have this pack, and we can go into our meshes and we can find something like flora, and we can take a palm tree here, for example, and say that this is the palm tree we want to make use of. So we'll go to our static mesh spawner. We need to add this static mesh here. We can do that by going to our mesh settings here, and we're adding a mesh entry. Adding a mesh entry, we can define which type of mesh we want to use and some other information. So we'll use this palm to spawn. So looking down here now, we can see that for each of these different, let's see if I can get a good view, like so maybe. So each of these points that we spawned will generate one of these trees now. You might notice that these different points have different colors. They are a density value. Essentially, it's a value between 0 and 1. So the whiter a point is, the closer it is to the value of 1. And darker one, black one being completely 0, so it's a gradient between 0 and 1 essentially. We'll get back to that in a little bit later to see how we can make use of that, but that's just something to keep track of for now. With these points, we can see that, okay, we're spawning trees now at all of these points, but this is a little bit too uniform, or there's maybe too many of them and things like that. So these are settings that we can make use of when it comes to our surface sampler, which is generating the points for us. The points per squared here, actually squared meter, will determine how many points you will have in a, how close together they will be essentially, how many there will be in a certain area. So if we were to have a lower value here, you can see that now we have just a tenth as many as before. When you have a value like this and you change the looseness, you can get more or further or closer away from each other. So if we do 2, you can see that we're getting further away. 0.5, they will be more clumped together. And this also takes into consideration, so if we were to have like 0.01, something that's really close, and then a really high number here, you can see we're generating we're basically packing them next to each other. Now the point generation bounds will be determining how many we will be putting here. So in this case we have 100 by 100 by 100, so that is X, Y, and Z. If we were to do 50, 50, you can see that we're getting 4 times as many, twice as many in each axis essentially. So these are numbers that you can make use of to, let's reset this to normal, to change how many and what kind of a distribution they have in relation to each other like that. Now the points here are being generated as well, first of all, I can see that these palms are very, very bright. Let's actually do something about that because they don't look very good. So if we take this palm tree, this one, open that up, go to this material. This material seems to be having an emissive, that might be the issue. Let's set that to 0. That looks much better. And there was one more material here. Let's go for the leaves and say that we want 0 there as well. Okay, that looks better. Now we have something that looks a little bit like palm trees at least. Yeah, so coming back to what we were talking about here. So these points have a weight to them. So in this case we only have one type of mesh that we're spawning. Let's say we wanted to spawn in more meshes, 2 different meshes or something like that. We could include it in as a new index in our mesh entry, add it like so, and in here we'll go instead of where did we go from here? We have meshes, we have our flora. Let's say we want to have these flowers. So we'll put in these flowers like so. And now we have two different meshes that we are generating out into this position. So you can possibly see that some of these boxes might not be too clear. We'll deactivate the debugging by pressing D, and it's more easy to see that because these boxes, the sample points, are taking up the space of the plants. So now we're getting 50-50 spawning here. So if we wanted to have like a larger amount of plants than we wanted to have trees, for example, we could go into our static mesh spawner and make sure that it has a higher weight. How weights work are they will take all the weights that exist of all the mesh entries, combine it together, and the amount of plants that will be its weight divided by how many there are in total. So in this case we have 2 1s, so 1 divided by 2, 50% of all the plants. If we're instead pushing this number up to 3, there would be 75% because 3 out of 4. So using that we'll get much more plants over here but much fewer trees. Of course you don't need to do it like this because there might be a point in separating. So you have like one surface sampler where you have a certain amount of settings for your frequency and their looseness and their different point extents, and then having that for trees, and then you can do another one and you'll do that one for plants, and then another one that you do for rocks, and so on and so forth. So important to note there is though that you want to have a surface sampler probably that's separate from each other, because if you were to use the same surface sampler here and then static mesh spawn of this, again they are spawning from the specific sample that we have created here, so then you would have multiple meshes in the same point. That's not what I wanted to do. So if you were to do this and this one was to be your rocks, for example, they would spawn inside of the trees. That's not likely what you want. This system is deterministic, which means that given the same parameters, you will get exactly the same result. To emphasize this a little bit, if we have this volume here and we move it, you can see that it updates. We get new points and it redistributes all the different plants and trees and such. So both the position, your settings, and its seed will determine what the configuration will look like here. So a seed, you can see a seed if you click on the surface sampler, for example, you can see that it has a seed here. A seed is a unique identifier for a randomized event, meaning that given this number and all of the other settings, this is exactly how it will look like every time you do it. So you can have a seed to make sure that, okay, I know that this is the result I will get in this occasion. To demonstrate this, we could go to something, I don't know, we can have these 2 trees here, for example, and the 2 white sample points between them. If we were to change this value from a 7 in the end to an 8 and press enter, you can see that it completely changes how everything looks. But if we go back to the seed, put it back to 7, you can see that we again have our 2 trees and the 2 white sample points in between. So that is what a seed is good for in this instance. So the system is completely deterministic, and that's a really good feature, so you don't actually get everything random all the time and you get something that you really like the look of and then you accidentally move something and now you're never getting it back, for example. This way you know that if you change a parameter you can always change it back and you'll have it exactly what you wanted to have to begin with. So now let's say that we're happy with the trees and everything like that. We think that the positioning of them is fine. It doesn't look very good because everything is identical here. So we might want to infuse a little bit of randomness to this. What we can do is we can right click and go transform, and you have something called transform points. This will take an input of points, which is what we have gotten from the sampler. We can put that in here, and you can change some things here and get an edited output of points. So if we disconnect these for now, we bring this back in together like so, and we were now to go and change some values here. We can see we can set some offsets, we can set rotations, and we can set scales. So in the case of rotations, for example, it has a min and a max. This means that these are the different rotations that it will be randomizing in between. So if we were to have 360 here as max, that means that it will randomize the z-axis, which is what the third column here represents. It's x, y, and z. And that means that it will be somewhere between not rotational at all and a full rotation, a whole rotation essentially. So pressing enter now, you can see that all the pawn trees, they changed a little bit. Let me see if I can adjust my mouse speed a little bit here. Like so. So you can see that they have rotations, they're looking in different directions and everything like that. Now you get some more randomness, which makes it look much better. You can also change something like the scale, because not all trees are the same size. So these are again X, Y, and Z. And generally when it comes to objects, you want to keep a uniform scale. So you might want to have the padlock locked so that it changes all the three values at once. So in this case, a 1 represents its full height and size as it's normally modeled, which we can essentially call 100% of its height. So we can go to the minimum one and say maybe 0.8 here, and we'll get somewhere between 80% of its height to 100% of its height distributed among all of these different trees randomly. Now, since this is a very small difference in height, it might not look like it's very apparent. So just to show it off, we can take something like 0.1, and you can see that some of these palm trees have become really, really small now, and some of these are really, really big, or at least normal size. So that's something you can do as well to make it a little bit less uniform, a little bit more random, and making it look a little bit more realistic. So let's talk a little bit more about these density values here, these ones that have black and white sample points. These we can determine in a few different ways. So for example, if we were to go to, let's see here, it is under density. You can see here we can apply a certain amount of parameters or properties from something and have its values changed. So you can have something like height would drive your density value, or your normal, meaning that it would change depending on its normal, essentially. It's what to call it? It's leaning in the world. And distances and noise and all kinds of different things here. So you essentially can manipulate what these density values will become. Then once you have a density value based on different parameters, you can say, well, I won't allow certain things. So you can like exclude certain heights or certain leanings and things like that, depending on their different values on the density value here. To show that off, we can see that we already have density values here from just placing them out in the world. And if we were to type in filter, you can see that we have a density filter. And let's disconnect this one and go to the spawner over here. And we can say that we want to filter out certain values. So by default, it says we only want the values between 0.5 and 1. This means that it's the most light of the different sample points. So if you look here, if we remove, you can see that we have a bunch of black ones here, the 3 black ones here. We remove the debugger here, so make sure that it's not obscuring the model below. You can see that there's not anything actually spawned under there. Putting it back again, you can see that we have one here in the gray, and we have some here in the slightly lighter ones. So filtering allows us to cull out certain parts depending on things like if it had a certain height or had a certain leaning and things like that, depending on the values that it gets. And of course you can change these values. You can like put it between the 0 and 1, and we would have exactly what we had before. All of the different points will generate a result. Situations where this could be useful could be something like maybe you want to have snow spawn on, or certain snow flora spawn high up on mountains but not further down, and then maybe further down you would have more warm kind of flora. Maybe on mountain sides you wouldn't want to have trees spawning, things like that. So you can like configure different properties that should affect different parts of partly generating your points, but also filtering out the results for spawning in different meshes or other objects in that case. Before showing the next part, some tools that can be useful is, in addition to the debugging, which is of course very useful to see your different values and where you generate your points, you might want to get a little bit more deep, and that way, a way you can do that is right-clicking and going into Inspect. Inspect will not show anything unless you have a specific PCG selected. So in this case, we only have one PCG in the world here. So going to our debug object here, you can see that the PCG test that we created earlier, and there we go. So now we get this box down here. Let's actually get some more space for this one. So here we can see a bunch of information related to this then. So we can see here the different points that were generated and where and how. And you can see a bunch of different information here. So this is good, and we can also see the amount of points. So we have 255 points generated here, which is something that can be nice to keep track of in some cases where you generate a lot of points. In addition to that, we also have the ability to make use of, let's see here, if we go do it like so, and we go to Windows and Profiling. Here is a profiler that allows you to see the performance of what you're creating. So if you have something that is very large, a very large set of procedural generation, then that would affect how quickly it spawns into the world. So in this case, we have something that takes 3 milliseconds, which is basically no time at all, because again, procedural content generation like this is available for you both in real time in game and as well as in editor. So it could be something that you spawn while playing the game as well. And at that point, you might want to have the ability to keep performance checks to make sure that you're spawning in a reasonable amount of time, depending on when you need to make use of it. Now, you're not limited, of course, to just static meshes and things like that, like we have shown so far. If we close this down, let's create another PCG. We'll go over here, we'll create a... Come on. There we go. PCG graph, we'll call this one PCG actor. So this PCG, we can do something similar. We can say, okay, we want to have a volume in the world. So we'll drag out the PCG actor in the world like so. So now we have that volume here. We can say that, okay, we want to generate points. So we'll go like this. We'll go sample. Let's take surface sampler again. We want to make use of surface sampling. We go for the landscape again. Let's say we wanted to generate points. Also, let's put the debugger on so we can see that. Let's say we wanted to do something that's like not constrained within the just the volume. We want something that covers the whole landscape. We can go to a little bit occluded, like we go here to our surface sampler. We go to unbounded. Clicking on that. And again, be a little bit careful when you're doing this because we're putting in a lot of samples now in the world. You can see that we put samples just not inside of the volume, but on the whole landscape on the level here. So that's a lot of samples. Again, we can go to our PCG actor and we can say inspect on this. We can see what kind of a result we're actually getting. We're generating 254,000 points, which is maybe a little bit too much. So let's again drag this out like so. And let's reduce the amount of points to maybe 1 in 100, something like that. So now we have a bunch of points here, but much less, 4,000 of them. And we have done static meshes before. We're not limited to that. Let's create an actor. So we'll go to a new blueprint class. We'll create an actor. We'll call this BP_actor test. And just to give it a visual representation in the world, we'll add a static mesh inside of this one. Like so. And we'll make sure that the static mesh is something like, I don't know, the sphere or something. Compile and save. Now we can say that we want to make use of this actor instead in the world. So going to our spawners, we can see that we have something like a spawn actor. We can say that for each of these points, we should spawn an actor. And in the settings of the spawn actor node, we go and say, under the template actor class, we say we want to have, what did I call it, BP actor test. Like so. And now you see that we have spawned our actors all over the world here. So since they are now actors, they could have their logic in them. They could be something like, I don't know, gold pickups or something like that, or health potions, or who knows what. And again, you could drive this logic in the same way. You could make sure that it's supposed to be in certain areas. You could configure the seed. You could configure it's only supposed to be in certain heights, or other kind of parameters to filter out the variation. So this is a way that if you don't want to author exactly all the different points for a pickup, you could use this tool for something like that as well. So there are a lot of possibilities when it comes to this. The imagination will probably be the limit. So since this is only in an experimental phase already, there's a lot of promise here, and hopefully there will be a lot of cool things done to this, and hopefully we'll get a lot of cool new features with it as well moving forward. All right, let's just do a quick little recap of what we have gone through. So in our test here, we have a input, which is getting information from the volume that you place in the world, a PCG volume. You can then make use of something like a sampler, which can generate you sample points in the world depending on a few different settings. So you can have a bunch of point data generated. From this point data, you can, for example, filter out some of them depending on properties and things. You can also translate them in different ways to have them varied, and then you can do something like spawning meshes on these different points as a result. Now you can see that I don't actually have this connected out here. I do believe that this works sort of like a function. It will auto end here if you don't connect it up. Maybe it's good to do so regardless, just to be like consistent. But yeah, so hopefully this has given you a first glance and understanding of how PCG works in Unreal Engine 5.2. Do note that this is 5.2 preview 1. So this is like the first iteration available. A lot of the things that we do here might look very different in the future. So some of this information might go out of date eventually. Anyway, that's going to be all for now. Keep on learning. Take care. Hopefully you found this video helpful. If you liked the video, leave a like. If you did not like it, leave a dislike. Leave any suggestions or comments you have down below. Subscribe and share this video if you want to see more like it in the future. That is all for now. Keep on learning. Take care.